Hello, everyone, and welcome to our second set of notes for this unit. This is about the Pythagorean Theorem. Hopefully, this is something you've seen before, but I know a lot of you may have forgotten it, so I wanted to make this video just going over it so you have access to these notes. So the Pythagorean Theorem is specifically about a right triangle. It only works for right triangles. So we need to clarify that. It's only for a triangle with a right angle in it. And all it says that in a right triangle, the square of the hypotenuse, remember this is the longest side of the right triangle, equals the sum of the squares of the other two sides. So this is about figuring out the side lengths in a right triangle. Typically, you may have seen this before. It is written as a squared plus b squared equals c squared. A very famous theorem in mathematics. C is the hypotenuse. I would label this if you're worried you're going to forget it. That's super important. C has to be the hypotenuse. It doesn't matter which leg is A, which leg is B. They're each one of the legs of the right triangle. And the Pythagorean theorem is useful for two reasons. For one, we can use it to check whether a triangle is a right triangle or not. So we will do that right now. Make sure you've got these down. Pause if you need to, because I will go to the next slide. All right, so we're using this to check whether a triangle is a right triangle or not. We've got one over here. Remember, the longest side is the hypotenuse. If it helps, you can label it just so that you don't forget. And we're going to use our theorem, the Pythagorean theorem, a squared plus b squared equals c squared. So c, remember, has to be the hypotenuse. So we'll put in 5 for c. That'll be 5 squared. Doesn't matter which one's A, which one's B. So we'll call 3A, 3 squared, plus B will be 4. 4 squared equals 5 squared. Now this equation should be true if this is a right triangle. So 3 squared is 3 times 3, that's 9. 4 squared, 4 times 4, that's 16. Equals 5 squared, 5 times 5, 25. You can check this in your calculator, but 9 plus 16 does in fact equal 25. So this confirms that this triangle is in fact a right triangle. If these two numbers had not been equal, that meant that this was not actually a right triangle. Someone had made a mistake, or they had just labeled the angle wrong. So this tells us because they are equal, it is a right triangle. But this isn't the only reason the Pythagorean theorem is useful. It's also useful because, and I'm going to pause here if you need these notes, because I'm going to go on to the next slide. It's also useful because it can help us find the missing sides. So here in example number 1, you'll see we have a right triangle. We don't know what x is. We want to figure it out. So we're going to use the Pythagorean theorem to figure that out. We can use the Pythagorean theorem to find missing sides of a right triangle. That's what goes in the blank here. So in this case, we'll again write the theorem a squared plus b squared equals c squared. Remember, c is the hypotenuse, it's the longest side. In this case, c is x. So instead of c, we'll just put x. A squared plus b squared equals x squared. A, it doesn't matter which one. We'll say 6 is a, plus b will be the other one, 8. So we know that 6 squared plus 8 squared equals x squared. 6 squared is 6 times 6, which is 36, plus 8 squared, 8 times 8, 64, equals x squared. 36 plus 64 is 100. 100 equals x squared. Now, that is not the length of this side. That is the square of the length of this side. So we have to think to ourselves, what times itself equals 100? Hopefully you recognize that 10 times 10 equals 100. So if 100 equals x squared, then 10 equals x. So that will tell us the length of this side is in fact 10. So that's how we can use the Pythagorean theorem to find a side of a right triangle. Now, if you can't figure this out, when you have x squared, you can use square root on your calculator. It's a button that looks like this. I can show you in class. That will find the missing side of the right triangle. All right, Let's look at this second example, which I have covered by my camera. Okay, again, we have a triangle. We are going to use a squared plus b squared equals c squared. And it's important to note c is always the hypotenuse. That doesn't mean it's always going to be the variable. In this case, c is 12 because that's the side opposite the right angle. So we'll put 12 squared in for c. This is a very common mistake. Doesn't matter which one is y. We'll say that y is a. That's what we're trying to figure out. Y squared plus 8 squared equals 12 squared. Now we'll go ahead and do the math. 12 squared, 144. 12 times 12. 8 squared, 64. 8 times 8. Y squared, we don't know. We're trying to figure it out. This is where we'll need to use a little bit of algebra. So we want to get y by itself. So we'll do minus 64. Minus 64. 144 minus 64 is 80. And that's going to cancel out here. So we know y squared equals 80. Now, again, this is where we need to use the square root. What is the square root of 80? I don't know this off the top of my head. It's probably going to be a decimal. So I'm going to get out my calculator and do the square root of 80, which it tells me equals 8.94. It's a decimal that goes on for a long time. I'll round it to the nearest hundredth, 2 decimal places. So that tells me that y equals 8.94, approximately. So this is how we can find the missing side of a right triangle if it's one of the legs. In this case, the hypotenuse we already knew. We had to find out the other leg. I hope this is helpful. If you need more help, ask a classmate or ask me in class, and have a good one. Bye-bye.